All right, so now let's draw some graphs. So this first graph we're going to draw is y equals 2 to the x minus 2. Because my base is a 2, which is greater than 1, I know this is going to be a growth graph. So, where we're kind of going with these, like graphs are great. Graphs mean you're actually plotting points, but I also just want you to kind of have in your head, what are the features? Like when I have a transformation like that, will it affect my asymptote? Will it affect my domain, my range, my y-intercept? And then we're going to kind of tie that together in a note. So if you have something like this, I'm going to think of my base graph of y equals 2 to the x. So I'm going to draw on here y equals 2 to the x because it's good to get used to it. It goes through 0, 1, and then it goes 1, 2. When x is 2, y is 4. And you can do this with table of values. When x is 3, y is 8, right? And then it decays the other way. And I'm never very precise about my decay. I might, whoops. That could do better. Okay, I'm going to go through here. And then I'm going to grow. Okay, this is my y equals 2 to the x graph. Now, in another color, let's pick a darker green. That's a nice one. What are the transformations here? Well, it's in the bracket with the x, so you have to think back to chapter 2. Is it a transformation on x or a transformation on y? If it's in the bracket with x, it's a transformation on x. If it's not, it's a transformation on y. Now these ones are really nice because being in the bracket with the x means you have to be in the exponent with the x. That makes it a transformation on x. So this is going to be right 2. So to graph this, if you know your base graph, you can take every point and move them right 2. So this point's going to go right 2, right 2, right 2, right 2. This was a half, so I could move that right 2. This was a quarter, so I could move that right 2. But really, I'm just approaching this asymptote. This is a graph of y equals 2 to the x minus 2. Now looking at this graph, where's the asymptote? Well, it didn't move. It's still y equals 0. What's the domain? It's still negative infinity to infinity. What's the range? Well, it's still 0 to infinity. And what's the y-intercept? Well, that changed. To find a y-intercept, you're going to let x equal 0. So we would get y equals 2 to the 0 minus 2, so 2 to the negative 2, or a quarter. So this graph has a y-intercept at 0 and a quarter. Now, I just did that whole thing via transformations. But don't forget that they gave me the equation. They gave me y equals 2 to the x minus 2. And this isn't like chapter 2 where I'm really testing transformations. This is kind of testing your knowledge of an exponential graph, and you should be able to expect the shape that you're going to get. So you could use a table of values. I could choose values of x and solve for y. I could put in something like -2, -1, 0, 1, 2, 3, whatever it takes to sort of get that shape. And it could be a good way of checking your points too. So for example, if I put in x is 2, I get y to the 2 minus 2, which is y to the 0, which is 1, 2 to the 2 minus 2, which is 2 to the 0, which is 1. There's my point, 2, 1. Maybe let's pick another one. Let's pick 4. When x is 4, I get y equals 2 to the 4 minus 2, which would be 2 to the 2, which is 4. So I should have a point 4, 4. So this is not like chapter 2, where you don't have the equation, you can't check. This is chapter, whatever we're in, 5, where you can check. You will always be given the equation. So if transformations makes you nervous, graph using a table of values, and that's totally acceptable and completely fine, okay? But you should have a knowledge of what the transformation would be. You might just be struggling putting it on the graph. Okay, so I recommend you pause the video and give this one a go. Start with your base graph, y equals 2 to the x. And whether you sketch it or not, that's up to you, right? 0, 1, 1, 2, 2, 4, 3, 8. And I won't trick you. I'm going to try to pick really a base 2 or a base 3 or a base of a half, because I want you to, not be struggling with drawing the original graph. I want you to think about the transformation. Okay, so pause the video, and I want you to think about what transformation is going to happen, and then how does it affect things? What happens to your asymptote? So on and so forth. All right, so hopefully you paused. Now my transformation, it is not in the bracket with the x, so this is going to make my graph go down 2. Well, what does that mean? Well, it means that every point on my graph is going to come down 2. So I'm going to start with this one, 1, 2. This one, 1, 2. This one, 1, 2. Down, 2. What about these ones? I have a half. Okay, it's going to go down maybe to about here. maybe to a quarter down here. I'm struggling a little bit. Maybe it would be good to think about that asymptote. Can asymptotes move? I used to have an asymptote at, here we'll do blue, at y equals 0. I used to have an asymptote at y equals 0. But now my entire graph has shifted down to, can I now get y values that are less than 0? Yes. Okay, so this is actually going to have an asymptote shifted down to, and I like drawing the asymptote because it acts as my guide. So now my asymptote has moved down here to y equals -2. So now when I sketch, I'm going to go towards that asymptote, and then I'm going to grow infinitely. Okay, this is my graph of y equals 2 to the x minus 2. What did it affect? Well, my asymptote is now y equals -2. My domain is still -infinity to infinity. My range, that's different. Now it starts at -2 and goes up to infinity. Is there anything that would change that? And then my y-intercept, again, don't try to guess, just plug it in. So y equals 2 to the 0 minus 2. 1 minus 2 is -1. And again, it's there. So my y-intercept is 0, -1. All right, next one. This one's a doozy. So I've given us lots of space to figure out what our equation actually means, and then we're going to graph this. So unfortunately, there's more than one way of doing this one, which I know is sometimes kind of frustrating. But when I look at this, the first thing I'm going to do is write this in a way that makes a bit more sense to me. I'm going to write this as y equals -1/2 to the 2 minus x. I could rewrite this as y equals negative. Now, 1/2 is 2 to the -1 to the 2 minus x. And I could graph -2 to the -2 plus x, which I would rewrite as -2 to the x minus 2. Okay? Or with this one, now, again, if you're reading, not again, but if you're reading the textbook, they're going to do this very differently than me. For me, because of my experience with other work, I think it's really good to know that if you're going to do your transformations in the order of like A, B, C, D, so that's all your stretches and your shrinks and your reflections first, and then you're going to move on to your translations, so left, right, up, down, you have to write the x value first. And then for me, I'm going to factor out that negative. So I've got -1/2 to the negative x minus 2. If you do it like this, what I want you to see is that you're going to have a reflection of the y values, right? That's going to go over the x-axis, over x-axis, This negative here is going to reflect, that's not how you're supposed to reflect. It's going to reflect the x values over the y-axis, and then this is going to move it right too. This is my preferred approach. So if you're going to keep it as a base of 1/2, I prefer you write it like this. You cannot see the horizontal translation unless you factor the coefficient off of x, and that means any coefficient on x. Okay? The textbook would graph this, and they would start the same. They say reflect y values over x-axis, and then they change the order on me. They go like this. They go left 2, and then they reflect the x values over the y-axis. But they're very, like if you're going to do it this way, let me finish writing, y-axis. If you're going to do it this way, it's really important that you go 1, 2, 3. Versus mine, I go left to right. 1, 2, 3. Okay? All very confusing. Okay? But if you're reading the textbook, they write their transformations differently. Okay? They say left 2 and then reflect. I say reflect and then right 2. It's going to end up doing the same thing, but it's a bit of a different mental process. Or if you made your base at 2, you could simply reflect y values over x-axis, and then you could just go right 2. So looking at this, right, we have three options. 1, 2 is my order. We have three options. Option 1 is to graph the way the textbook does. Option number 2 is to graph the way that I would graph this, just purely from my kind of classical training in transformations. I used to mark provincial exams, and it was really important that you understood, even in chapter 2, which they didn't do any of these in the textbook, but like if there's a coefficient on x, you have to factor it out to see your translation. And so I'm so stuck on that I have a really hard time with number 1, but it is accurate. Or number 2 or number 3, right? You could graph using a base graph of y equals 2 to the x. So it doesn't matter to me which one you do. I'm just in my head trying to decide which one I want to make for the video. Maybe what I would say is pause the video, you choose. Choose 1, 2, or 3. So you're going to take your base graph and then you're going to do transformations. Now, your base graph is either y equals 1/2 to the x, which will go as a decay, or y equals 2 to the x, which is a growth. And then I would pick some key points and transform them. Or plug in values of x and solve for y, right? It doesn't matter. So knowledge of transformations, no knowledge of transformations. But regardless, actually, before we even graph this, we could figure out our asymptote, our domain, my range, and my y-intercept. So let's do that. So asymptote, is there anything moving this graph up and down? No. So my asymptote, I'm expecting it to be y equals 0. Domain, well, it's always negative infinity to infinity. And then my range, is there anything weird happening here? Well, I have this reflection of the y values over the x-axis. So what that's going to do is, instead of my range being 0 to infinity, it's actually going to be 0 down to negative infinity, because there's a reflection of the y values over the x-axis. And then the y-intercept I would just find by plugging in x is 0. I would do it into the original equation. So we've got negative 0.5 to the 2 minus 0. So I'm expecting my y-intercept to be, I'm going to write this as negative 1/2 squared, so it's going to be negative 1/4. So I'm expecting, no matter what transformation I do, right, what order or how I graph this, I'm expecting to get a y-intercept of negative 1/4. Okay, in my head, what am I going to do? Well, I think the easiest one is number 3. So I'm going to graph this guy. So I'm going to graph y equals negative 2 to the x. So the first thing I'm going to do is reflect my y values over x-axis. And then I'm going to negative 2 to the x minus 2. I'm going to move it right 2. Doesn't matter, right? You can do any of these 3, but I just feel like this is the easiest. So I'm going to start with my base graph. I'm going to start with y equals 2 to the x. So I'm going to go through 0, 1, 1, 2, 2, 4, 3, 8. I'm going to grow, and then I'm going to approach my asymptote. Okay. Now again, you can do this step by step. You could reflect it. So I could take all these y values and put them upside down, so reflect them over the x-axis, and then move those points to the right too. Or I could take some key points and transform them, right? I've got a point like 0, 1. What's going to happen to it? Well, I'm going to reflect the y values. So I'm going to times the y values by negative 1, and I'm going to move it right 2. My new point will be 2, negative 1. So this point, when it gets reflected and moved right 2, would go to here. This point, so I've got a point 1, 2. I'm going to reflect it in the y values, and I'm going to move it right 2. I'm going to have a point 3, negative 2. 3, negative 2. Maybe I try one more. So let's try this point 2, 4. 2, 4. I'm going to reflect the y values and move it right 2. I'd have a point 4. I hate my 4s, sorry. 4, negative 4. Okay, 4, negative 4. All right, so that's kind of got me this part. Now let's take a point like maybe negative 1.5. So the last point that I'm going to transform, just to get that shape, is going to be at negative 1.5. Again, I'm going to reflect it. So I'm going to times the y value by negative 1, and I'm going to move it right 2. So I'd have a point 1 and negative 0.5. So at 1, I have negative 0.5. So now I can kind of see the shape. I'm going to go like this. Now, just because I'm me, I just really want that point here to aim for. Okay, there's another point. And then I'm going to approach this x-axis. There we go. And again, I would get the same thing if I took the y equals 1/2 to the x graph. I reflected it, so you can picture it kind of being the decay. Reflect it in the x values. Oh, now I'm at y equals 2 to the x. Then reflect it in the y values, and then go right 2. So, you know, number 3 and number 2 really match. It's that same reflection and moving right 2. The biggest difference is with number 1, right? So they do left, and then they reflect it. And I just can't handle that, but totally up to you. And again, I want to remind you that if you were confused, don't be afraid to make a table of values, x, y. Plug in a point, like maybe let's plug in x is 4. If I plug in x is 4, and again, I would plug it into the original equation in case I've messed something up, I would get negative 0.5 to the 2 minus 4. So that gives me 4 again, minus 4. So that gives me negative 0.5 to the negative 2, which would give me 0.5 to the negative 2 is 4. That would give me negative 4. So I should have a 0.4, negative 4. Oh, look at that, I'm right, right? Give yourself ways of making yourself feel good that you did it right. All right, last thing. So last thing before we move on to part, oh shoot, sorry. I just did a huge video. I meant to take a break. So the next thing is just looking at how did those transformations affect my graph? Well, let's look at my original graph. My original graph is y equals 2 to the x. My asymptote is y equals 0. My domain is negative infinity to infinity. My range is 0 to infinity. And I have a y-intercept at 0, 1. Okay, transformations that will change this value. Well, to change the asymptote, your graph has to move up and down. So there has to be this plus d on the end. That means that your transformed graph will have an asymptote at y equals d. What about your domain? Well, your domain, nothing changes it. It's always going to be negative infinity to infinity. What about the range? Well, there's two scenarios. Scenario 1, you have y equals 2 to the x plus d. And so there's no reflection of the y values, which means that your range would be d to infinity. The other option is that you get a reflection in the y values. So you have negative 2 to the x plus d. And so instead of being d to infinity, it would be d down to negative infinity. And lastly, the y-intercept, everything. Everything affects your y-intercept. Find it by let x equal to 0 and solve. All right, that is 5.2. I'll try to split this video up. Oh no, there we go, there's part 2. Okay.